Okay, Bismillah Rahman Rahim. So today we're going to start our topic number 3, and this is the atomic structure. As we discussed in the previous lecture, that the unit of matter is what? Atom. Now we'll talk about in detail that, okay, atom is the smallest part. So what is inside the atom? Now we will talk about the different features or different you can say points which have been discovered in a period of time. First of all, atom is the smallest component of an element. We have discussed already this one. The atom is made of two main regions, the nucleus and in the center and electron shells around it. They're saying that if you talk about atom, so you can divide it into two main parts. For example, if this is the atom, in the atom you'll find two parts. This is the center of the atom. It is known as nucleus. And you will find the shells or orbits around the nucleus. So this is the second part. They are known as shells. Sometimes they are known as orbits. Sometimes they are also known as energy levels. So different terms are used, same for the shells. So if you talk about the nucleus and the shell, so they together they make the atom. And if you will go in further detail, okay, this is a nucleus, but what is inside the nucleus? What is inside the nucleus? So said that nucleus has two things inside it. Number one is proton and number two is neutron. Both of them, they are inside the nucleus. For example, you see their location, so both are inside the nucleus. And in the shells around the nucleus, what you will find? Electrons. There are more than 20 subparticles in the atom, but here we will talk about only these three in your syllabus. So now we'll talk about proton, neutron, and electron. And as we said that protons and neutrons, they are found inside the nucleus, and electrons, they are found around the nucleus in the shells or in the orbits. If you talk about the symbol, so for proton, we are using the symbol H positive. H positive. Why? Because they are considered equal to the hydrogen atom. For neutron, they use the symbol N. Some books you'll find for proton P and for neutron N. And for electron, you have E. So this is their symbols. If you talk about their charges, so proton has positive 1 charge. Neutrons, they are neutral, they don't have any charge. And electron has negative charge. If you talk about their mass, so proton is 1. 1 they are just taking as a unit, AMU, atomic mass unit. So this is you can say like you're using kilogram, gram like this. So when you're talking about the atomic subparticle, so they are using a unit AMU, atomic mass unit. According to that, it is 1. Proton is same like neutron in the mass. In other words, you can say they are almost equal in the mass. But if you talk about electron, its mass is really, really low or very small. So when you are talking about its mass, and if you compare it, if you are going to compare this one, for example, the mass of electron is 1. For example, this is, mass of proton is 1. And if you talk about electron, how much? So if you divide the mass of proton into 2000 parts. In other words, if you have one, you will divide, and you will get the 2000 parts of one. So that will be equal to the mass of electron. In some books, you will find 1 over 2000, and some books you will find 1837. So this doesn't matter, but here the numbers are showing that the electron mass is really less. It means that if you want to neglect it, if you want to consider it as a zero, so it's not wrong. It's almost nearly to zero. So this is how they are talking about the subparticle. You have proton, neutron, electron. Proton have symbol H positive or P positive. Neutron is N0, electron is E0, then E negative. Then charge, proton has positive charge, neutron doesn't have any charge, they are neutral. Electron has -1 charge. Mass of proton and neutron, they are same, and the mass of electron is really small. It is 2000 times less than the proton and neutron, so it is almost zero. The location, the proton is in the nucleus, neutron is also in the nucleus, and electron, they are found in the shells or orbits around the nucleus. So now we'll see that with the help of a diagram. Okay. If you talk about this diagram, you can see here, this is the nucleus, this part. Inside the nucleus, you have two things. One is neutron, they described with the N, and other is proton. They put a positive sign because proton has positive sign, positive charge. And these are the shells, and in the shells you have the electrons. So here they have taken the example of lithium atom. If you see the lithium, it is the third element in the periodic table. And if you see the periodic table, you will find lithium written like this. And this upper one, this number, it shows the atomic number. The upper one shows the atomic number. What is the atomic number? The number of protons in an atom, it's known as proton number. For example, now you have three protons inside it. For example, here we can see how many protons? One, two, and three. Three protons are there. So its atomic number is known as 3. It means, what is atomic number? Atomic number is the number of proton inside the nucleus. So this is known as atomic number, or sometimes it's also known as proton number. After that, if you see 7, what is 7? 7 is atomic mass. 7 is atomic mass. What is atomic mass? If you add proton and neutron together, so that is known as mass number. For example, if you see here, how many protons are there? Here 3 protons. How many neutron? 1, 2, 3, 4. So 3 and 4, total 7. So it is 7. So whenever you see the periodic table and you will find these numbers, so first number means atomic number or proton number, and down one is named mass number, or sometimes it's known as atomic mass. Mass number also known as atomic mass, and atomic number is also known as proton number. So upper one is atomic number or proton number. What is that? Number of proton. And down one is the proton plus neutron. That is known as mass number or atomic mass. Is it clear?
Yes.
Now they are talking about the atomic structure rules. Now they're saying that atom has no net charge or neutral because the number of proton and number of electrons are same. For example, now they're saying that in the previous example we talk about lithium. In lithium, how many protons were there? 3. How many electrons were there? 3. Proton has positive charge, so we can say plus 3. And electron has negative charge, so we can say minus 3. So if you will combine both of them, so 0. It means that in an atom, you should know. This is a rule. Whenever they talk about lithium atom, sodium atom, potassium atom, aluminium atom, any atom, so number of proton is always equal to number of electron. And due to that, atom always neutral. Atom always neutral. Atom does not have any charge. Why? Because the positive charge of proton is cancelled by the negative charge of electron because they are equal in number. So first rule, that in an atom the number of proton and electron same, so it doesn't have any charge. This is rule number 1. Rule number 2, the number of proton in an atom equal to atomic number of the element in the periodic table. So they're saying that the whatever the number of proton, that is equal to atomic number. We just discussed now when we saw that lithium, here is 3 written and here is 7 written. We said that what is 3? We said that that is atomic number. So in the periodic table, what is atomic number? It is equal to number of protons. So this is the second rule. Third rule, the definition, what is an element? We already discussed in the previous one. Element is made of atom of the same atomic number. For example, if you have lithium, inside this lithium you have lithium, let's say you have 4 atoms of lithium. Atom number 1, atom number 2, atom number 3, atom number 4. So if you see this atom, what is proton number or atomic number of this atom is 3. What is the atomic number of this one? 3. So in an element, all the atoms, even it has millions of atoms together, all of them, they have the same proton number or same atomic number. Once again, a substance made of atom with the same atomic number, it is known as an element. Rule number 4, the number of proton of an element never changes. It determines the identity of the element. Now, when you talk about the atom, you know that protons are inside the nucleus and electrons are around the nucleus. So they said that number of proton never changes unless you will break the nucleus. And breaking the nucleus happens only in nuclear reactions, in radioactivity. But normally, when you're talking about chemical reaction, number of proton remains same. So in other words, you can say if lithium has proton number 3, so there is no any element have the same number. It is known as its identity. Every element has its unique atomic number, and other elements, they cannot have the same number. So this is the number of protons of element never changes. It determines the identity of the element. Then 1, 2, 3, 4, number 5. The elements in the periodic table are organized by their atomic number. If you see the periodic table, in the periodic table, you will find two things. Here you can find the groups like this, and then you find the periods in this horizontal line. So they in the periodic table, elements are arranged according to their atomic number. For example, here hydrogen 1, then you have helium 2, then you have lithium 3. Okay, then like this 4, 5, 6, 7, 8, 9, 10. So like this in periodic table, elements are arranged according to their atomic number. Let me see if we have a periodic table here. I can show you now. For example, this is a periodic table. Yes, no, it's blank, but hydrogen is here. This one. Then you have here helium. Then you have here lithium. Okay, like this. So they are number one, atomic number two, atomic number three, four, five, six, seven, eight, nine, like this. They are going like this. So they are arranged according to their atomic number or proton number. This is rule number 6. Now they're saying that next thing, the number of protons, the number of proton plus neutron, together they make what they made, they known as mass number. Mass number also known as nucleon number. If in the exam or in the book you find the nucleon number, so no need to worry about that one, because nucleon number is the other name of mass number. So mass number means proton plus neutron. So nucleon also means proton and neutron. For example, the mass number of lithium is 3, its nucleon number is also 3, just like another name of that one. Next, the number of neutron could change for the same element, and so it is the mass of the nucleon number. So they're saying that the number of neutron could change for the same element. So then it means that we study what? The proton number cannot change, but the mass number can change. How it can change, I will give you the example. Maybe you heard the word of isotopes. Isotopes, for example, we have hydrogen. Hydrogen has one proton, one neutron. But an hydrogen atom, there's another hydrogen atom which has one proton, but it has two neutrons. Means here it doesn't have any neutron. Here it has one neutron, and here it has two neutrons. For example, here you know that if you see here, what is the proton number? 1. Mean one proton, it means one electron. So here it is mass number down. Mass number always proton plus neutron. So here no neutron, only proton. So 1 plus 0, 0. So first hydrogen atom, it does not have any neutron. Second one has one proton plus one neutron. So it is 2. Other one has one proton, two neutron, that's 3. So all are hydrogen atoms. All are hydrogen atoms. They are belongs to which element? Hydrogen. But they have different mass number. Here mass number 1, mass number 2, mass number 3. So if they have different mass number, why they have different mass number? Because different number of neutrons. Here no neutron is 0, here neutron is 1, here neutron is 2. So they are saying that in an atom the proton number remains same even in the isotopes. So what is the proton number here? 1. What is the proton number here? 1. What is the proton number here? 1. All 1. Only what is changing? Mass number or nucleon number. And why it is changing? Because here one neutron, so here is no neutron, one neutron and two neutron, like this they are changing. So this is that they are talking about that the number of neutron could change for the same element. So that is known as nucleon number. Then the atoms, then we have atoms that have the same proton number but different neutron number are called isotope. Just we discuss now. For example, carbon. Carbon, you know that it is a element in the periodic table. It has its mass its proton number is 6. But carbon has 3 isotopes. What is that? Here 6, here 12. Other 6, 13. Other 6, 14. In all, proton number is same. What is the change? Neutron number. Here how many neutron? 6. Here how many neutron? 7. Here how many neutrons? 8. So all these three are known as isotopes of what? Hydrogen. Next, the number of electron does change. The atom more or fewer electron than proton are called ions. We talk about atoms. We said that in an atom, the number of proton always equal to number of electron. If it is 6, it is 6. If it is 10, it is 10. If it is 1, it is 1. But in what? In an atom. But you know that during the bonding, especially ionic bonding, what happens? Atoms lose electron. If an atom will lose electron or it will gain electron, the number of electron will be changed. If the number of electron is changed, then it will not be equal to number of proton. At that time, if an atom has different number of proton, the number of proton is not equal to number of electron. At that time, we cannot say it is an atom. We say it is an ion. If protons are more, so it is known as positive ion. If electrons are more, it's known as negative ions. So this is the difference between an atom and ion. Once again, atom number of proton electron always same, due to that charge is 0. But in an ion, the number of proton electron, they are different from each other. If proton are more than electron, it's known as positive ion, or if it is less than electrons, it's known as the negative ions. Next, the number of electron does not change. The atom with more or fewer electrons than a proton are called ions. Atoms that have more electron than proton are negative ions. So negative ions also known as anions, another name for them. Atom that fewer electron than proton or positive ions are called cations. So this is the two types of ions, positive and negative. Negative is known as also anions, and positive also known as cations. Any confusion?
No.
Okay. Now electronic configuration. How you will, what do you mean by electronic configuration? Is really simple. You know that if I will say, okay, there is an atom A, it has how many electrons? Let's say it has 6 electrons. How many proton it has? If it is atom, so also 6. How many neutron it has? Let's say 4. So I will say, okay, draw its structure. Draw its structure. So what I will draw? I will say, okay, I will draw the atom. First of all, I will draw the nucleus. This is nucleus, the center. So I will write here proton is 6 and neutron is 4 because they are inside the nucleus always. After that, I will draw the shells because I have to put electrons also. So I will draw the first shell. So there is a rule that in the first shell, you can put maximum 2 electrons. It means total 6. Now 2 has gone, 4 are left. It means I have to draw another shell. So I will draw another shell. So in another shell, this is the second shell. So I can say in first shell, how much I put? 2, maximum, because you cannot put more than 2. In second shell, how much maximum you can put? 8. But how much we have now? 4. So the remaining 4 we put here. 1, 2, 3, 4. So here we draw the atom. And how we draw? Because they have given us atomic number, proton number. This one I draw. So when you draw it, atom in such a way, that is known as electron configuration. Electron configuration. Okay. So here, if you will see in more detail, for example, now they said lithium. Draw for lithium. And what is lithium? They said 3 up, 7 down. So 3, what we said? Proton, how many? 3. So electron also 3. And neutron. So neutron is really simple. Neutron equal to mass number minus proton number or atomic number. So what is mass number? 7. Atomic number 3. So what is the answer? 4. So neutron is 4. So whenever they will ask what is proton, how many protons are there, you see the atomic number same in an atom. If they say, okay, how many electron, same like proton. But if they will ask you how many neutron, just minus these two numbers, you will get the number of neutron. So here, how I can do, I want to draw, so I can draw like this lithium in the center. And then first shell, how many you have? Here I draw the first shell, 2. Second shell you have 4. So this is electronic configuration. See, draw the nucleus with the symbol of element in the center. This one. Draw the number of electron shells according to the period number. Now you know the periodic table. In the periodic table, you know that the lines like this, they are known as periods. And the line like this, they are known as groups. If any element is in period 2, in which line, let's say there is an element lithium, in which period? This is period number 2. It means it can has only 2 shells. In other words, period number will tell you the number of shells. If any element is period number 6, it means you have to draw the 6 shells around it. So it is also a shortcut. If you want to know that how many the you can say shells you will draw, so see its period number. Then the third one, start filling, as we said that closest. So inner shell can have 2, next shell has 8, then 8 again like this. So this one you how to draw this one. So they have given here the example. For example, see here. Now here they have given sodium. You can see sodium. Let's say sodium. Sodium is 11 and 23. So if I ask to you, okay, sodium is 11. So how many proton in the sodium? 11, because same number. Okay, how many electrons? 11. How many neutrons? So 23 minus 11 to 12. So you have to draw electronic structure. So here you wrote sodium. So how many, first shell, how many electrons can come? Total 2. So first shell is 2. So in 11, how many left? 9. In second shell can have maximum 8. So 8 will come here, 1 left, it will come in third one. So the last shell is also known as valence shell. And the electron which is in the last shell, it is also known as valence electron. So this is the how they will do this one. Now I want to draw the electron structure for beryllium. So how I will draw? Okay, first how many protons are there in beryllium? The number of protons,
4.
how much? 4, good. How many electrons?
9.
No. Proton always
5.
equal to electron. If 4 proton, 4 electron.
4.
And neutron, how you will find? This
4
minus
minus 9.
So 9 minus 4 equal to 5. Now we know that there are 4 protons, 4 electrons, and 5 neutrons. So I will draw
Yes.
a circle. So before in the center, I will write what? I will write, let's say, beryllium. So I will draw the first shell. In the first shell, how much I can put maximum?
2.
2. So total 4. I put 2 here, 1 and 2. Then in the second shell, how much I can put maximum?
The maximum is 9.
8. Maximum I can put 8 in second shell.
9 or
There is
8.
a rule.
Yeah.
First shell,
Yes. Yes.
you can put 2 maximum. Second shell, 8 maximum. Third shell, also 8 maximum. So here I put 2. Out of 4, I put in the first 2. So how many left? 2. So 2 I put
2.
here. So this
Yes.
is the electronic structure of this one. Now, Ahmed, you will do for me the magnesium. So magnesium, you will tell me how many protons?
12.
12. Good. How many electrons?
12.
12. How many neutrons?
And 12 too.
24
Uh,
minus 12.
12.
So 12. So, okay, I will draw the first shell and in the center, I will write magnesium. In the first
Magnesium.
shell, how many I can put?
2.
2. Okay, good. And now I will draw the second shell.
2. You
Second
put
shell
8.
maximum 8. Okay.
Yes.
So 1, 2, 3, 4, 5, 6, 7, 8. So do we need the third shell also?
Yes.
Yes. So in third shell, how much left?
2.
2. So one here or one here. So this is the electronic configuration. Yes, Ahmed
Yeah.
also got, other Ahmed, you also got this one?
He's not here.
Okay, it's showing any. So this is how you will draw the electronic structure for an atom.
Yes.
Okay, now we'll move to the next. That is isotopes. Isotope, we have just discussed now that isotopes are the atoms of the same element. They have the atoms of the same element. They have the proton number same, all atoms, but they have different mass number. Atomic number is same, but mass number is different. And why the different? Due to the neutron, because every have the different number of neutrons. So again, the definitions: atom are the same element with the same proton number or atomic number, but different nucleon number or mass number. So they are known as isotopes. Isotopes are written using their symbol and the mass number to the upper left, atomic number to the nearest. For instance, the sodium isotope is written as like this. There are three isotopes. There are, sorry, two isotopes of that one. So you will write them in a different way. For example, you have, I told, give the example carbon. Carbon is an element. It has three isotopes. Here 6, here 12. This is known as carbon 12. Other one is known as carbon 13. Here 6, here 13. Next one is carbon 14, 6, 14. If I will say protons, all of them have 6 protons, 6 protons, 6 protons. If say electron, 6 electrons, 6 electrons, 6 electron. If I talk about neutron, 6 neutron, 7 neutron, 8 neutron. So everything is same in the all the atoms, but only neutron is different. Due to neutron number different, they have the different mass number 12, 13, 14. So these are known as isotopes. Known as isotopes. You can divide the isotopes into two categories: radioactive isotopes and non-radioactive isotopes. Who are the radioactive isotopes or radioisotopes which release the radiation, which their nucleus will release the radiation. So why? Because their nucleus is not stable. Nucleus is not stable. Due to that, it is no release the radiation. They are known as radioactive isotopes. And non-radioactive isotopes are made of atoms of same element with different masses but the stable nuclei. For example, we studied now carbon has three: carbon 12, carbon 13, carbon 14. So this carbon 14 is a radioactive isotopes, or radioisotopes, because it releases the radiation. Other two, they are not radioactive. So this is the main difference between them. Now they are comparing the isotopes. If you see the isotopes, so their number of proton same, number of proton similar, but they have number of proton same, yes. Property of isotopes, number of proton same. Then number of electron also same. Number of neutrons, they are not same. Atomic number same. Mass number not same. Chemical property is, you can say, same. But now if you talk about here the other one, different properties, number of protons. Now the similarities of and differences between isotopes are summarized here. Okay, number of protons, they are similar property in all. Then number of electron, it is also similar property in all. Number of neutrons, no, they are not similar, they are different. Atomic number similar, yes, not different. Mass number is not same, all are different. Chemical properties are similar, they are not different. So this is the main difference between isotopes of the same element. Did you get this one? Using the isotopes. Now, isotopes have similar chemical properties, as we discussed now in the table. They have the same chemical properties because why? They have same number of valence electron, or in the last shell, they have the same electron. For example, now we have discussed three isotopes. Now, I said first one, carbon 12, then carbon 13, then carbon 14. If I draw the structure for this one, so I will draw the first element. This one, how many electrons? 6. So first 2, other 4. If I draw this one, so first 2, other 4. Same one here, 2 and 4. So it means isotopes have the same chemical properties because they have the same number of valence electrons. How many valence electrons are here? 4. How many valence electrons are here? 4. Valence electron mean the number of electron in the last shell. Isotopes have two major applications where these isotopes are used. Number one, they are used in medical purposes. So, but in medical purposes, why they are used? They are used to kill the cancer cells. Then they also used to sterilize medical equipment. Before the operation, they are sterilizing everything. So they are known used for their. Number two, industrial use. Uranium 235 is used to generate electricity in a nuclear power station. So these are two uses. In the exam, if they ask a question, what are the uses of isotopes? You can say there are two uses: medical use, what, killing cancer cells and sterilizing the equipment. Number two, in industry, what is this one? They're saying to produce electricity in a nuclear power station.